Hi everyone. So in the last video, we've seen that you can use RBD guides to drive your RBD simulation with another object that you animated. In this video, you want to look at another cool thing you can do with it, and that is you can add detail to your simulation after you've already simulated it. So the idea here is the following. Let's say you have a simulation like this, something really simple, just a box that breaks apart. That was fractured before by an RBD material fracture. And now you say, okay, I really like how those pieces are fall apart, but of course the amount of detail is really lacking here. So now you say, okay, no problem. I just create more pieces in my fracturing, like here, and then I just run it again. But if I do this, of course, the behavior of my pieces will completely change. I have a completely different setup and therefore a completely different result. How do I solve this? Now, the trick is to just take the result of the first simulation and then with the help of the RBD guide, just feed it into a second simulation with more pieces and then guide my second simulation with the pieces of the first one. And what you get out of it is basically the same behavior of your simulation, just with more pieces to it. And I really like this technique for multiple reasons. First of all, it's much faster to iterate over it because, of course, working with way less pieces is much faster than working with a lot of pieces, of course. Also, if your client, for example, your director, likes your destruction, you can still add more detail without destroying the overall behavior that was already signed off by the client. And thirdly, it simply allows you to control how your simulation should look. You can start with the broad strokes, make sure they look fine, and then you can, without losing anything, run a second batch of simulation where you really only care about the detail without losing the overall character. So this is a pretty cool technique. So let's have a look how to set this up. So what we have here is pretty straightforward. We have just a box and an RBD material fracture, nothing too crazy. And then we simulate it with a collision ground, of course. So that part should be straightforward for you. And now, in this case, what I just do is I take one of the first frames where the box is not yet destroyed, usually that's the first frame, and steal it from my simulation. I could also do it, from the beginning, it doesn't really matter. But in this case, I do it from the simulation. So with a time shift, I just steal the first frame of my simulation. There you go, by just breaking the frame parameter. And before I move on, one thing that is important, whenever you work, and that's a general rule in Houdini, whenever you work with the result of one simulation in another simulation, make sure that you clean up your geometry. And by that I mean all the attributes that come out of it, which to be fair are not too crazy in this case. But in our case, we don't need velocity or W or the name attribute or anything. We don't care about all those things. So what we can do is we can use an attribute delete to delete everything we don't care about, which in our case is really nothing, so we delete everything. Or there's another node, by the way, called the clean node that does the same for you. Delete everything and also fix a couple of things. So an attribute delete or a clean node can help you here to get rid of your attributes that you don't care about. And now I put this into another RBD material fracture, now that the geometry is clean, and just fracture this whole thing again. To make it more visible, I turn off the fog noise, so that we have an even distribution for both levels. And maybe I add a few more pieces for the second level, and I think that should be fine. Doesn't really matter for this case. Of course, you can put a lot more work into this to make it look nice. And now this will get its own RBD bullet solver. So far, nothing special. But of course, what will happen now if I add a collision ground plane is of course a new simulation with the new pieces, which is not what I want. So by the way, actually, let's lower the constraint stiffness a little bit, so maybe to 1000. And what we will get is, a completely new simulation. But what we can do instead is we can just use the result of the first simulation as the guide for the second simulation. And for that, of course, we need an RBD guide setup. Make sure that your pieces are packed, otherwise it will not work, unfortunately. But we don't want to overwrite the name attribute, so we only want to pack it. And then we take the result from the first simulation as our guides. Make sure you also connect the guides here. Let's have a quick look, because looking through the RBD guide setup will when we press enter, give us a preview of the whole thing where we can see if everything worked, and it did not. Why is that? Let me see. Okay, this was actually something I wasn't aware of. Again, this whole setup here has changed in Houdini 19.5. But this is the cool thing about the RBD guide setup. It shows you as a preview what's going on. And if it doesn't work here already, then you don't even have to simulate it. And you can already kind of debug the whole thing before you even start simulating it. So the problem here is actually, just like the RBD guide setup expects a packed version of your fracture geometry, also the guide setup needs to be packed. And all we have to do for this, of course, is just add an assemble to our original simulation without a name attribute, because we already get that, but only packed. And now, of course, the simulation itself has not changed. It's just the same. But what you can see here, it's one more reason to always make it a habit to always pack your geometry before it goes into the RBD solver. It just makes everything easier. And here I wasn't even aware of it. So now when I take the result of the original simulation, the broader simulation, and middle click on it, you can see it is packed. And now when we look through the RBD guide setup, you can see now it works, and it even gives us a proper preview of how this will look like without even having to simulate it. And now if we look through the final result, of course, as long as the guides are enabled, it looks like this. It takes our original simulation as a guide and then drives our finer simulation with that original simulation. So pretty cool, pretty powerful to really art direct your simulations. And if we put those next to each other again, you can see that they are really based on the same movement. Here you go. And you can see how well this whole thing works. Again, if you have jitter problems with your second simulation, in this case, it's not a big deal, but then keep in mind you can lower the blend mode. Just be careful, if you lower it too much, then they will not stick as well to the original pieces. So maybe be careful in a case like that, where you really want to follow them strictly, and maybe 0.5 is then a bit too high. You can try something like 0.8 or something. But this is something you have to play around with. It's just, you know, about the overall idea. So this is just a box, a bit boring. So let's quickly look at at least a little bit more interesting example. So what I have here is our squab breaking through the ground in a really cartoony fashion. And you can see, obviously, if you don't have enough pieces, it looks very cartoony and boring. Now, of course, you can always increase the amount of pieces, and then it looks like this, and it's pretty slow. So let's quickly do a flipbook of this. And you can see it has way more pieces, and therefore it is more interesting. But, you know, they're all the same size, and it kind of feels boring. Doesn't really feel like there's concrete breaking apart. And I wanted to show you with this example because the next step is where we used what we just saw. We take the first broad simulation and drive the second finer fracturing with that first simulation, and we get a really nice result that looks like this. And here you can see the result is that you have those big pieces that are connected with the small ones, and it feels, to me at least, much more natural because you have this distribution of big and small, because the small pieces are driven by the big pieces from the first broader simulation, which just results in a nicer, more realistic distribution of fracturing. Of course, that's not the only way of doing this. We've already learned that you can use RBD clustering for a similar effect, but I still like the approach of, you know, having broad, simple, rough simulation first and then increasing the detail afterwards without breaking the behavior of the first one. So I hope this is helpful to explain that you can use RBD guides for a secondary fracturing system, which in my opinion is pretty powerful. So yeah, thanks very much and see you later. Cheers.